Good morning, students. Welcome to the class of Technomathematics. So today we'll be learning rational numbers. Okay, what are rational numbers and what are the different concepts underlying, and we will discuss the properties of the rational numbers, and also what are how to insert rational numbers between two given rational numbers. Okay, like that. So our topic for today is rational numbers. Rational numbers. So students, in rational numbers, what is a rational number? A rational number, a rational number, the numbers which can be represented into the form of P by Q, right? If we are representing a number into the form of P by Q, and when this denominator Q is not equal to 0, then this is your rational number, right? You can take some examples like uh, let's say 3 by 7, right? 2 by 5, right? And you can represent even 8 by 11. All these are the examples of rational number, right? And we will understand what are the properties which are followed by the rational numbers. Okay, so if any rational number just multiplied by a positive number, then it can be said that, let's say, this is a rational number 3 by 7, okay, and this is the rational number 2 by 5. If you compare it, if you compare both the rational numbers and try to convert it into equivalent, okay, to convert this into equivalent rational numbers, what to do? Hi Trevor, hello. So to convert two given rational numbers into equivalent rational numbers, what we do? You just compare the denominator of both, right? Thank you, Trevor. Thank you so much for your compliments. You can see the denominator 7 and 5. So here you can see 7 and 5. You need to compare and convert it into equivalent one. So here you can see 7 and 5. When you just take the LCM of 7 and 5, it becomes 35. I hope this is clear to you. So you need to convert the denominator of each of the given rational number to 35. To do that, what you will do? If 3 by 7 is given to you, just multiply this with 5, then only the denominator becomes 35. And when you are multiplying the denominator with 5, you need to multiply the numerator also. So now the fraction, now the given rational number becomes 15 by 35. This is your first. 3 by 7 becomes 15 by 35, right? Similarly, the second rational number, what's that? The second rational number is 2 by 5. So 2 by 5, we are just learning comparison of rational numbers, okay? So 2 by 5, to convert the denominator 5 into 35, you need to multiply it with 7, right? When you are multiplying the denominator of any fraction with any number, then you need to multiply the same number into the numerator also. Then only it will be equivalent. Okay, the fraction will be same, the value will be same. So now it will be becoming as 14 by 35. So this is very simple. Suppose you are having a bread, okay, or you are having a circle, and it's cut into equal parts of 35 pieces, right? Suppose this is, let us assume it, okay, then 1 2 3 4 5, like that, till 35. Then Here you are taking 15 out of 35 and here you are taking 14 out of 35. So which one is greater? Which one is greater, tell me? Definitely 15 pieces out of 35 is greater. So this is always greater, right? So we can say that this is 3 by 7. Since 15 by 35 is greater than 14 by 35, we can say that 3 by 7 is greater than 2 by 5. So this is your answer. So in the comparison, what did you found? You found that 3 by 7 is greater than 2 by 5, right? So similarly you can handle or you can solve multiple questions, but just follow the same trick. Just see the new denominators of both the given rational numbers and take the LCM and convert it into equivalent. To convert into equivalent, multiplying the same number into the numerator and denominator of the fraction, but take care that denominator should be equal to that LCM, right? So in this way we can compare any rational numbers and we can say which one is greater, which one is lesser, which one is having bigger. You can see I shown it over here, like fractions. Okay, just convert it into like fractions and then you can say which one is greater. Now coming to the property, any rational number, let's say a by b, right? I represented it with p by q also. So don't get confused that it's y a by b by p by q. It's a simple number only. Okay. So hi Burak, you know mathematics. That's perfectly fine. Thank you so much. You are very good. You are a nice person. So if this is a rational number, okay, and if you are multiplying this with any number, right, non-zero integer, any non-zero integer, let's say if you are multiplying this with what are the integers, the numbers starting from minus infinity till minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. All these are integers, right? All these are integers, right? So when you are multiplying this with any integer, right, into the numerator, then same need to be same, but with the same integer you need to multiply the denominator also, right? Integer. Then this rational number a into integer, right? A into multiplied by integer divided by b into integer, this will be also a rational number with same value as a by b, right? This will also having the same value as a by b, right? So this is a property. We can multiply an rational number with an integer with the same integer into the numerator and into the denominator, right? And as we can multiply with an integer, we can also say, we can also you can also as we can multiply, we can divide it by an integer and the value will be same. And just mind it, this integer should always be same. No difference of integer should be there. Just a minute, there is some power failure. Let me switch on, right? So here you can see, if you are dividing it with an, right, then the value, that means a divided by integer and b divided by integer with the same integer, this should be same, right? Then this value is always equal to this one, that is a by b, right? This value is always equal to the same integer. I hope you got it, right? Now coming to the another part, another property. So this is property 1, that you can multiply a rational number with any integer, with the same integer, into the numerator and denominator, and the value of the rational number becomes same, right? Similarly, you can divide it, right? Now, coming to the third property, what's that? Sorry students, actually there is a power failure, so that's why you maybe you're not able to see it properly, but no worries, I will continue today's session. Now, in between, yes, thank you so much. Now the power resumes. Yes. Now, if you want to represent a rational number, these are the two properties which are followed. Okay, you can multiply it, you can divide it, right? Now, the third property, let's say if a by b is a rational number and another rational number is there, let's say it's a c by d. It's a c by d, right? And the values of these are equal, and if this is an equation given to you, if these are equal, then by cross multiplication you can see a into d will be equal to b into c. This can be written, this is another property, right? So this can also be done. We have learned what things we have learned. We have learned comparison of rational numbers, right? But we'll take more examples on comparison. How to turn equivalent a rational number to given rational numbers as equivalent. Okay, how to compare two rational numbers, just definitely by turning it into equivalence. We are doing the comparison, right? Now what we will do, let us learn about the representation of the number line, right? Suppose representation on number line. Now we will be learning representation on number line. So in representation on number line, what we will learning, let us see. Let me change the page, just a minute. This is we are going to learn representation on the number line. Representation on number line. Students, I hope you are aware of the x-axis, y-axis, the number lines, right? So I'm considering that. So let us take some example. Let's say, let us draw the number line first. This is minus x, this is plus x, right? This is plus x, and this is minus y, and this is plus y. So if you want to represent a rational number, let's say you can take any example. Let's say 13 by 5. 13 by 5, or you can take another line, another number, 1 by 3. Let us take some simple example first. 1 by 3. This is in the proper format, right? You represent it on the number line, right? What you will do, this is 1 by 3, so that means you need to from 0, right? From 0, if you are going to 1, this is 1, right? Then the denominator is 3, you can see. So before reaching 1, you need to divide this 1 into 3 equal parts. Let's say 1, 2, 3. So we can represent this first part as 1 by 3. This section should be such that this section should be equal to this section, and all three sections should be equal to each other, right? Then this section is 1 by 3, this will be 2 by 3, and this will be equal to 3 by 3, right? So 1 by 3, how to represent 1 by 3? It's simple. 1 by 3 is here, 1 by 3 is here. So this is the representation of 1 by 3, right? Suppose you have a question that represent any other number, let's say 4 2 by 3 on the number line, 4 2 by 3. So what you will do, you can see 4, so that means it can be written as 4 plus 2 by 3, right? So on the number line, if this is the origin, just count 4 first. Okay, so 1 2 3 4, so it's 1 1, changing the pen, 1 2 3 and 4, right? And after 4, it will be 2 by 3. So till this point 4 is okay, 4 is okay, but we need to add this 2 by 3 along with 4, right? So from 4 and before 5, okay, as we did over here, just this section need to be divided into 3 equal parts as shown into the denominator of the number which is left after 4. So we divide this 4 to 5, that means this unit of 1, into 3 equal parts. Let's say this one and this one. Then we can say this point, this is 1 by 3, and this point is 2 by 3, and this is 3 by 3, right? Now this point can be represented as 4 1 by 3, right? This is represented as 4 1 by 3, right? And the second point between 4 and 5, which since we have divided into 3 equal parts, this can be represented as 4 2 by 3. So in this way we have represented 4 2 by 3, right? Hope you understand. We'll take more examples, don't worry. I want this concept to be very much clear so that you can understand the number line and representation on the number line. Let's take another example, 2 2 by 5. We are taking another example, 2 2 by 5. Okay, representation on number line. So you can see 2 2 by 5 can be written as 2 plus 2 by 5, right? 2 is a whole number, so representation of this whole number on the number line is not a very big task for you. I know you guys are very smart, you can do it very easily, right? So it's 0, it's 1, it's 2. So for 2, it's very simple. You are representing this point, let's say A, and you will say, yeah, A is a point on the number line representing 2. That's the whole number. But the main thing lying for representing 2 by 5. Okay, you can see 2 plus 2 by 5. So just consider this 2 by 5 to be represented before 3 and after 2, because this is added with 2 plus something, so plus is 2 by 5, right? So plus is 2 by 5, that means the next section from 2 to 3, this is for 2 and this is for 3, this unit is 1 unit, right? And this 1 unit to be divided into 5 equal parts. You can see the denominator. If you are, if I'm just taking one example, if you are having a pizza and having 4 pieces into it, then you can say this portion as 1 by 4, right? Because they are total 4 pieces. So in the denominator you are having the total number of, okay? So from 2 to 3, if this is 1, then the denominator should be 5. That means this 2 to 3 should be divided into 5 equal parts. So here you can see, if you zoom it, it's 1 by 5. You can zoom it, the second one is 2 by 5, it's 3 by 5, 4 by 5, and the last one is 5 by 5. So 5 by 5 is basically 1, right? So 2 plus 5 by 5 will be 3. So that's fine. I hope this concept is clear. So here we can say this number, let's say the first one, 1 by 5, this point will be equal to not 1 by 5, it will be 2 1 by 5, right? This second point is not 2 by 5, it will be 2 2 by 5, because we are already standing on 2. You can see here we are already standing on 2, so it will be 2 2 by 5, and this point is not 3 by 5, basically it's 2 3 by 5, right? It's not 4 by 5, it's basically 2 4 by 5. I hope you understand. And the last one is not 5 by 5, basically is 2 5 by 5. 2 by 2 5 by 5, that means 2 2 5 by 5, that means is equal to 2 plus 5 by 5, that means 2 plus 1, that is equal to 3, right? So basically this is 3, which was right, it's already 3, right? So in this way we can represent any numbers on the number line, right? Now we are going to I'm going to show the additive inverse. What is additive inverse? If the number line concept is clear, that's fine. If any question with you, you can write into the uh, comment box. Additive inverse. What is additive inverse? So for additive inverse, it's very simple. Additive inverse, that means any number, let's say 7. So the number plus its additive inverse, that means the number that need to be added. You can see the word add, okay? When the number added with that number especially, then let's say additive inverse, the sum of both the numbers will be equal to 0. This is the fundamental, okay? So here, if the number is 7, then to find the additive inverse, let us assume it as x. This should be equal to 0. So the value of x when 7 will be going to the RHS, it is equal to minus 7. So x equal to minus 7, that means the minus 7 is additive inverse of what? Our question, that is 7. Additive inverse of 7, right? So in this way, additive inverse concept, I hope it's clear to you. In additive inverse, I am again saying additive inverse of a number is the same number whose sign is just interchanged, right? Now coming to the multiplicative inverse, okay? What is multiplicative inverse? So the multiplicative inverse, just I'm showing it over here. So I'm showing the multiplicative inverse. Let's say multiplicative inverse. So for multiplicative inverse, what you need to do? Understand? For multiplicative inverse, let's say a number is there 7. We'll take the same example. We need to find the multiplicative inverse. So multiplicative inverse That means 7 with the multiplicative inverse of 7 will give you always 1. So the number and its product, the multiplicative number and its the product of the number and its multiplicative inverse is always equal to 1. Mind it. This is also called the multiplicative identity, right? This is also called 1 is also called multiplicative identity. This is question coming into exams many times. What is the multiplicative identity? Or 1 is the multiplicative identity. As we have learned into the additive inverse, 0 is the additive identity. Okay. So to find the multiplicative inverse of 7, let us assume this number as x. Then 7 multiplied by x will be equal to 1, and the value of x, that is the multiplicative inverse which we have assumed, is equal to 1 by 7. So 1 by 7 is the multiplicative inverse of this number 7, right? Multiplicative identity, additive identity, comparison of natural numbers, and representation on the number line, right? We have learned all that. Representation on the number line, you can see we have seen various examples over here. Okay, we have seen various examples over here. Now what we will do, what is left with us? Comparison we already did, representation, multiplicative inverse, additive inverse, and everything. So I think we can wind up the session for today now. Thank you so much for watching, students. Bye bye, take care.